Hello, advocates of health and wellness. This is Dr. Lewis Muchile, and I am so excited to bring you this video about bilirubin metabolism. Now, just like uric acid, when we talk about bilirubin, everybody is thinking of the worst. In uric acid, you're thinking of gouty arthritis. In bilirubin, everybody is thinking about jaundice. I will bring you a video about jaundice after this conversation, but I want to lay the basis so that you can understand jaundice. But we cannot understand jaundice without talking about bilirubin. However, bilirubin is a very important substance in our body. Remember, it acts as an antioxidant, all right? So it protects your heart, your blood vessels, even your brain from damage and oxidative damage for that matter. It also binds on heavy metals and poisons and toxins to help the body to clear it out. So it's a very important one, right? And then it is a very good indicator in terms of the liver health. That's why when you're doing that liver function test, you will see bilirubin there because it's an indicator of how your liver is doing. Because if it starts to build up, it means either you're breaking down so many red blood cells and your liver is struggling to release the bilirubin from the system, and now you start having this jaundice, the yellow eyes, the yellow skin, and the pale skin. Okay, so that is its importance. However, when bilirubin piles up above normal levels, we call that hyperbilirubinemia. So a lot of bilirubin in your blood, and this is supplied all over. That's why you start seeing the yellow eyes and the pale skin, because this is a yellow substance. So once it accumulates in blood, you start having that coloration of yellow on your skin and in your eyes, and that is now a medical condition called jaundice. Now, bilirubin metabolism. What do we mean by metabolism? How this bilirubin comes into surface, and then how it is broken down, and then how it is released from the system so that you end up having normal ranges of bilirubin. But I want you to understand this, that bilirubin comes as a result of breakdown of red blood cells, okay? So there are medical conditions, there are autoimmune conditions, there are medications, and other things, basically even normal breakdown of red blood cells, because red blood cells have a lifespan of 120 days, basically 3 to 4 months. So they have to be done away with. There are other red blood cells that are actually deformed, they are immature and all that, and they have to be destroyed in the system through the spleen. So a lot of medical conditions can actually cause the breakdown of red blood cells because bilirubin comes from a breakdown of red blood cells, okay, hemolysis. So we have a lot of conditions like sickle cell, like thalassemias, like the rhesus. On rhesus, you've seen that hemolytic disease of the newborn, where a difference in the rhesus factor in the mother and the child, and the father, sorry, brings a lot of problems in the child, right? So that is where we come in with the rhesus factor. It's called hemolytic disease of the newborn. We have infections, bacterial infections. We have malaria there. We have hemodialysis. People who are undergoing dialysis, a type of dialysis called hemodialysis, can actually lead to breakdown of red blood cells. Poisoning and toxins build up in the system. Pregnancy complications, some complications in pregnancy can actually cause breakdown of red blood cells, and then autoimmune conditions. And the one that is being diagnosed currently in literally every elderly person is the lupus. But most autoimmune conditions that target the red blood cells or the tissues can actually cause hemolysis, building up your bilirubin levels. However, even with these conditions, as long as you have a functioning liver, the liver will do the rest. It will just clear it out. And the liver clears out toxins by a process called conjugation. Conjugation means the liver brings this bilirubin, combines it with a substance that makes it water soluble so that it leaves the system. Anytime the liver makes something water soluble, it is easy to excrete through either stool or urine. Okay. Now, for this process, we have 4 organs that are involved. Of course, the first organ is the spleen, which is involved in breakdown of bilirubin of red blood cells to release bilirubin. And then we have the kidneys and also the gut, basically the large intestines that are involved in enterohepatic cycling and also excretion through stool or feces, kidneys excretion through urine. And then we have the liver, where the entire metabolic pathways happen, all right? The conjugation that makes it easy to excrete from the system. So let me take you into through a stepwise process of this breakdown, because once you understand this stepwise process, it will be easy for you to know when I'll be talking about types of jaundice and how they happen, right? And that is another video. Now, here you have our red blood cell, the RBC. Now, this RBC has served its function or it is disformed, or it's actually being broken down as a result of these medical conditions that are here. So what is happening? We are breaking them down, and this is happening in the spleen. So we break them down and we release hemoglobin. Remember that the red blood cells, the active part of it is the hemoglobin. This is the one that actually binds oxygen so that you can transport oxygen from the lungs throughout the system all over into the tissues. So this is the one, all right? So hemoglobin is two, a combination of two things. We have the heme and then we have the globin, right? So globin is a protein. Most proteins are made by the liver. So this is one of them that is actually made by the liver for the sake of this purpose. So we combine heme and globin, and these two give you hemoglobin to aid in oxygen transportation in the system. Now, the spleen breaks this down into heme part and the globin part. The globin part, which is the protein part, is recycled, goes back to form more hemoglobin and also other functions like carriers in the blood, okay? And then we have the heme part. Now, the heme part is basically the iron part. Realize hemoglobin is actually iron, has iron in nature, right? So we have iron, which comes in with the heme part, right? And then now the heme part is actually broken down into the iron and the bilirubin. So heme part, the heme part of the hemoglobin is the one that is going to give you bilirubin. When you break it down, you get the iron part. The iron is also recycled plus the globin, and then we get now the bilirubin. Now, this bilirubin that you're getting here is what we call unconjugated bilirubin. Why? Because it is insoluble. It cannot be excreted from the system. It will start to pile up, causing you more problems. So what do? The body understands that because your body is perfectly designed. So this one is carried all the way to the liver for now conjugation to make it more soluble so that it can actually be excreted from the system. Now that it has actually done, a part of it has done the oxidative protection part, it has protected your heart, your brain, and your system entirely. It has been used for liver function, so it's actually in the normal ranges. So the excess of it is carried to the liver for conjugation. Now, there is an acid in the liver that is called glucuronic acid. I always tell you, don't cram these words. Why? Because they are not as necessary as you think. What you need to know is the insoluble bilirubin is carried into the liver, and in the liver, it is actually made soluble for easy excretion. All right. So the acid called glucuronic acid is the one that is used for conjugation purposes in the liver, which happens to be our second organ. Now, in the liver, this bilirubin can be used for multiple functions. One can be used to make bile, all right? And that is stored in the gallbladder. This gallbladder is a very important organ there because it concentrates bile so that it can be available for digestion of fats in the small intestine. But when you have a gallbladder chopped off, that's a problem. They chop this out instead of fixing what is the problem. So now what will concentrate bilirubin? The bile. It means the liver will simply make bile, and bile will go direct into the small intestine when it's not concentrated, and the effects are actually minimal or subminimal. So we want it to go into the gallbladder, stay there for some time as it's being concentrated, so that it can actually be released into the small intestines. Okay, but that is a bile conversation. This is a bilirubin conversation. So a minimal amount of bilirubin is used to form bile, right? And then part of it, now after conjugation, we've made it soluble. When you make it soluble, it will simply be collected with these ducts and goes into the bile duct and then counters the pancreatic duct where we have pancreatic juices coming in. We combine them with these components that are coming in, the bilirubin being part of it, and they are deposited into the duodenum in the small intestines. All right, and then it's carried all the way into the large intestines. Now, that is the gut in the lumen. In the large intestines, we have bacteria or microorganisms. The role of these microorganisms is to basically either reduce this or oxidize it to form another substance. That substance is called urobilinogen. All right, so we've come out with conjugated bilirubin, came down through the ducts into the duodenum, carried to the large intestines. Now it has been actually oxidized or sometimes reduced by gut microorganisms. And then now this bilirubin, which is conjugated, is converted to urobilinogen. Now, urobilinogen is again oxidized or worked upon by gut microorganisms to form something that is called stacobilin. I hope you can actually understand these words, or you can actually get hold of these words. So stacobilin is the one that gives the poop the color. Your feces almost look like brownish green color. That is coming from the stacobilin, which tells you bilirubin is the one that is responsible for your stool color. All right. So after all these processes, we'll end up with stacobilin that will give you a stool color and now you release it out and it's gone. And now bilirubin levels in blood will go back to normal and the liver function will be perfect. Now, in the same large intestines, there is something called enterohepatic circulation or cycling or recycling, whatever word you want to use. So we have the portal system that carries substances from the gut into the liver, all right? Now that same portal system, you see part of this stacobilin that is forming, the urobilinogen that is forming here before it's converted to stacobilin. So the stacobilin, this will take 80% of the bilirubin. But the 20% will be taken back into the portal system for cycling, goes back into the liver, and in the liver, a small portion also is used to form the bile again, but a larger percentage of this that is coming from this cyclation, this recycling, will go into the kidneys. And in the kidneys, because the liver will release it into the system, into the blood, and the blood will find its way all the way to the kidneys for filtration. So part of that urobilinogen is going to the kidneys for filtration. When it gets into the kidneys, that's where we convert it to urobilin. Urobilin is the one that gives urine the color again. So it's excreted through the urine. All right. So we have one giving color to the poop, the stacobilin, and then the urobilinogen being reabsorbed back into the system, back to the liver. Liver takes it all the way into the system through the kidneys, and in the kidneys is excreted through urine as urobilin. So we have urobilin, we have stacobilin, and then we have urobilinogen. Understand that urobilinogen is as a result of microorganisms working on conjugated bilirubin so that you can get urobilinogen. And then urobilinogen is the one that is converted again by the same microorganisms to stacobilin. And again, urobilinogen is carried to the liver and then into the kidneys, converted to urobilin that is released through urine. And that's how you metabolize bilirubin. So you excrete it either through urine or through the stool. Now the challenge comes in here. If you have any challenges in this pathway of taking it all the way or even conjugating it in the liver or converting it by microorganisms in the gut to form stacobilin or reabsorption back into the liver so that it can actually be released in the urine as urobilin, that will start to build up. For example, if you have a liver problem, a fatty liver, that tells you your system will start building up so much of this unconjugated bilirubin because before it gets into the liver, it's still unconjugated. Now, this unconjugated bilirubin can actually cause you jaundice. That is one. So if you have a liver problem, let's say a fatty liver, liver cirrhosis, or all those issues that you have with the liver, the alcoholics, they are unable to metabolize bilirubin optimally so that you can actually excrete it. So it starts to build up, being toxic to the system. Number two, if you have any closure of these ducts, let's say you have a cancer of the bile duct or the gallbladder or cancer of the liver or cancer of the pancreas where you're blocking this pathway. So all entirely in this tube we are building up on the bilirubin. That starts to give you again another buildup of bilirubin affecting liver functions and also affecting your skin color and your eye colors. If you have a problem with the gut, let's say you don't have enough microorganism to help you in either reducing or oxidizing this urobilinogen into stacobilin, problems again. If you have even messed up gut in terms of IBS, you cannot reabsorb it back so that it goes and released through urine, more problems. But all these we'll talk about them when we'll be talking about jaundice, where we'll see that we have the pre-hepatic, and then we have the hepatic, and then we have the post-hepatic. Those are the three types of jaundice, and I'll talk about that in another video. I hope you've understood this bilirubin metabolism, and you can actually use this as a baseline to actually discuss the disease called jaundice.